Good morning, Year 9s. Welcome to this tutorial on ratios and direct proportion. It is a new topic to you guys. It does work on familiar concepts that we've covered before, so please reach out if you have any questions on Daymap or Teams, or if you require any support if you're struggling to wrap your head around these ideas. So just before you start, you will need your maths book today and a pen or pencil. You might want to copy down some examples that I complete, and you'll need to complete some examples on your own as well. Warm up. I'm going to give you an opportunity to pause this video and complete the warm up. How can you add 8 8s to get the number 1000? Give it a go, pause the video, and then click go when you're ready to start again. Always starting off with our learning intentions, so you'll be able to understand and distinguish between ratios and proportion by the end of this lesson. Firstly, you need to be able to define ratio and proportion. You need to be able to tell the difference or distinguish between a ratio and a proportion, and you're going to apply strategies to accurately calculate proportions. So let's get started. A ratio is a comparison between two quantities. For example, we often see ratios that look like this. So they're separated by a colon. So this is a ratio of 2 to 3. So if you put that into an example, that would be like saying for every 2 cakes a baker bakes, they make 3 cookies. Okay? For every 2 cakes, they make 3 cookies. So you have a 2 to 3 ratio of cakes and cookies. A proportion is an equation. That means it has an equal sign, in which 2 ratios are set equal. It shows the relationship between 2 ratios. Okay, so for example, a ratio of 2/3 is equal to a ratio of 6 to 9. Okay, so if you look at this, if we simplify this 6 to 9 ratio, a common factor of 6 and 9 is 3. If we reduce both these sides of the ratio by 3, so divide them by 3, 6 divided by 3 is 2. 9 divided by 3 is 3. So you can see by reducing these by the common factor of 3, we end up with 2 to 3. So a ratio of 2 to 3 is the same as a ratio of 6 to 9. I hope that's clear for you guys. We're going to go and practice calculating these on our own now. So pattern recognition and proportions. You guys are going to complete a worksheet that looks like this in a moment. I'm going to complete the first example for you now. But once I've done the first one here, I'm going to let you guys pause the video, have a go at the other 3, and then click back on when you're ready to see or hear the answers. If you're struggling, watch this the whole way through and then have a go once you get to the worksheet. So we're looking at the relationship between these numbers, okay? So we're looking at this way. So this is a proportion, 5 to 10. What did we have to do to the 5 to make it 10? Hopefully you can see that you're just multiplying it by 2. So what you need to do, what you do to the top, you need to do to the bottom for this proportion. So we're going to times 7 by 2, just as we did with the 5 to make 10. And you're going to see that this space here should be 14. Oh, Miss Carlson is not very good at drawing on the computer. So you should see that a ratio of 5 to 10 is the same as a ratio of 7 to 14. Hopefully you can see that 5 is half of 10, just as 7 is half of 14. So a ratio of 5 to 10 is equal to a ratio of 7 to 14. Now, I want you to stop the video here. I want you to have a look at the other ones and then click back on once you've had a go at completing these other ones. Draw these in your book as you see them in the boxes, okay? So pause the video and then we can get started again once you're ready. I'm assuming you have paused the video and you're ready to hear the answers. In this case, we need to look along the bottom, okay? All right, so we need to fill this space in at the top and we've got the 2 bottom numbers to help us out. What do we need to do to 6 to make 42? You might get your calculator out for this, or if you're good at your times tables, you should be able to see that to get 42 from 6, you need to do times 6 by 7. Okay, so we're going to times 6 by 7 to make 42. What we're going to do is times 8 by 7 to work out what this space is going to be. So 8 times 7 is, I'm going to give you a moment to guess, 56. Okay. So hopefully you guys can see the pattern that we're doing here. Same here, we need to find this missing square down the bottom. So we need to look at the relationship between 3 and 36. So 3 times what gives us 36? Hopefully we know our 12 times tables. We know that 3 times 12 is equal to 36. So we're going to have to do the same to the bottom. 2 times 12 is 24. So looking at these patterns. Now, 4 into 100 doesn't fit evenly. So what I like to do is I try and make this first square here 1. Okay, so to make 4 1, we just need to divide it by 4. Okay, and because this is a ratio, what we do to one side of the ratio, we need to do to the other side of the ratio. So a ratio of 4 to 100, if we divide both sides by 4, would be the same as a ratio of 1 to 25. So what we know here is that whatever number we have in this box here on the left is going to be multiplied by 25, and that will give us the number in the box on the right. So for every one cookie, we have 25 cakes. Okay? So here we need to multiply this 9 by 25, and you're going to need a calculator to do this because it's a big sum. So 9 multiplied by 25 to work out our blank space is 9 multiplied by 25 is 225. All right. This one is a little bit trickier because you have to do that additional step to reduce this ratio so that it is a 1 to something ratio. So take your time with these. The next ones we're going to go on to are a little bit trickier. So if you need to pause, wrap your head around these, please do. Okay. Next slide. Pattern recognitions and proportions. Again, these ones are trickier. I'm not going to go through all of them, but I do want to go through. I want you to try and complete all of them, but I want to go through the ones where decimals are involved. Okay, so we've got two numbers here. We want to find out the relationship between 2 and 7. It's not obvious. What we're going to do again is try and make it a ratio over 1. So if we divide both sides by 2, we have a ratio of 1 to 3.5. Okay. So we know that for each proportion, what's in this box is going to be 3.5 times bigger than. So 2 times 3.5 is 7. All right. So I'm going to let you have a go at the other ones, try and work them out on your own. We'll have a go at more of these once you get back to school. So I want you to have a go at these ones too. I've differentiated them as always, 1 star, 2 star, 3 star. I'm not going to go through the answers of these until we meet together tomorrow's lesson. Okay? I don't want to make this video too long for you. So now we're up to task 1. You need to access the proportion patterns worksheet on Daymap. Complete it in your book and then submit a photo on Daymap of proportion patterns by the end of the lesson. Okay. Once you've done task 1, you can move on to task 2, and task 2 deals with visual ratios and proportions. So we have 2 sets here, and we need to work out which set has more elephants per area. So it might be easy to look at this and say, well, set A has heaps more elephants than set B, but we're looking at per area. Okay, so in this case, we've got a 1, 2, 3, 4, 5, 6 by 3 area. So we have 18 units of area here. Okay, 18 units of area. And how many of those have elephants in them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 out of those 18 units of area have an elephant in it. In this case, we have 4 out of the 6 units of area containing an elephant. How do we compare these fractions? They're both over a different denominator. Hopefully you're all saying to yourself, we need to make sure we pop this fraction and this fraction over a common denominator. So by finding a common denominator, we can work through and have a look. What's a number that 6 and 18 go into? Well, both of them go into 18. So we don't need to do anything to this fraction here. So for set A, 13 out of the 18 have elephants in. But to put our area B, set B's area over 18, we need to multiply both the top and bottom by 3, because 6 multiplied by 3 is going to give us 18. And we're going to have to do the same to the top. So in this case, this set B has 12, because 4 times 3 is 12, of its 18 units with elephants in. Okay, so you can see that set A does actually have more elephants, because 13 out of the 18 squares of area have elephants, compared to set B, which only has 12 of the 18 squares of area covered in elephants. Okay, so by making a fraction with a common denominator, you compare these 2 sets in a fair way. Same here with the ants. We've got 6 of the 10 spaces in set A with ants in, and 10 of the 15 in set B. We can't compare these 2 fractions because they have a different denominator, so that's revision from last year. Let's pop them over the same denominator. 10 and 5 both have a common factor of 5. Okay, so to make 10 into 5, we need to divide it by 2. What we do to the bottom, we must do to the top. So 6 over 10 is equal to 3 over 5. That's just equivalent fractions. And same here, 10 over 15, if we're going to divide both sides by 5, is the same as 2 over 5. So if we put these areas over the same unit, 3/5 of set A is covered in ants, where only 2/5 of set B is covered in ants. Okay, so therefore, set A has more ants. All right, than set B. I hope this makes sense. It is a bit of an abstract concept, but it does rely on things that we have done in the past. Okay. Task 2, you need to access the ratio and proportion worksheet. Make sure you don't do that for task 1. and complete it in your workbook. Page 1 only. Page 2 and 3 are for Wednesday's lesson.